Hey everyone, and welcome to today's Explainer. Today we're unpacking the invisible force that's literally powering the device you're using to listen to this right now. We are looking at the ultimate showdown in electronics, AC vs DC power, and specifically the difference between alternating current and direct current. We're going to break down the mechanics behind the raw power surging through your walls versus the stored energy sitting in your batteries. Okay, let's dive into this. Here is our roadmap for today. We're starting with a quick refresher on the flow of electrons. Then we'll introduce direct current, bring in alternating current, put them head-to-head, and finally, we'll wrap up by covering a few other current types you might not be as familiar with. Let's get right to it. Section 1, the flow of electrons. So what exactly is current anyway? To make sure we're all on the same page, let's establish an absolute baseline here. Current is, quite simply, the flow of electrons. It's that fundamental movement of electrical charge that anchors everything. It runs our entire modern world, from massive citywide power grids right down to the tiny microchips inside your smartphone. But as you'll see, the specific way those electrons actually move dictates how the entire system works. That brings us to Section 2, direct current, or what we can think of as the one-way street. So in a direct current system, or DC, the magnitude of the current is completely constant, and it strictly flows in one single direction. Think of it exactly like a one-way street. It's a reliable, unwavering, constant push of electrons. Because it provides such a steady, predictable output, DC is the absolute perfect power source for the batteries inside our everyday household electronics, like laptops, phones, and TV remotes. Now let's see how this builds, because here's the catch. Your home's wall outlets don't naturally spit out DC power. So to feed your devices, you actually have to follow a quick three-step process. First, you start with the alternating current coming out of your wall. Step 2, you run it through a device called a rectifier. And step 3, you get direct current. That rectifier literally forces that bouncing, oscillating grid energy into the flat, one-way street that your battery requires. Which leads us perfectly into Section 3, alternating current, the two-way path. Unlike that steady, flat line of DC we just talked about, alternating current is a completely different beast. Its magnitude changes continuously, and its direction actually reverses periodically. If you were to map it out, it follows a sine or cosine curve. The electrons are constantly oscillating, pushing and pulling in a continuous, wavy rhythm, rather than just marching straight forward. Now, what's really interesting about this is why we use this undulating current for our homes and local utility supplies. It comes down to one massive game-changing advantage. AC can be easily transformed between high and low voltages. Power plants can step the voltage way up to push electricity across hundreds of miles of transmission lines super efficiently. Then, transformers step it right back down to a safe, usable level right before it enters your home. All right, Section 4, the AC versus DC matchup. It's time to compare our heavyweights. When we really look at AC versus DC power, the core difference between alternating current and direct current, it honestly just comes down to flow topology. It's a battle of the waves. DC is your steady, unwavering flat line, moving strictly in one direction. AC, on the other hand, is your continuous dual-direction wave, where the magnitude is constantly changing. In the real world, we interact with both of these every single day, and they're constantly working together. While your batteries run on DC and your house runs on AC, we use conversion tools as a bridge. An inverter or a motor generator can flip DC into AC. On the flip side, as we mentioned earlier, rectifiers can smooth AC out into DC. These clever little tools are what allow these two drastically different electrical systems to seamlessly coexist in your life. But all of this naturally brings up a pretty fascinating question. Are AC and DC really the only types of current out there? Let's find out in Section 5, Other Types of Current, the supporting cast. First up, we have steady current. With steady current, the magnitude absolutely does not change over time, and it flows in a perfect, continuous loop. If you were looking at this on a graph, it translates to a perfectly straight, horizontal line. It is the literal definition of a continuous, unwavering flow. Next is varying current. Now, with this type, the magnitude actually does change over time, but here's the catch. The direction remains entirely constant. So unlike alternating current, which physically flips its direction back and forth, a varying current strictly maintains its one-way path even while its intensity is bouncing up and down. Finally, we have instantaneous current,
This is literally the exact value of the current at a microscopic fraction of a second, like a single millisecond. It's an incredibly crucial measurement for highly variable events, things like rapid charging and discharging. It basically gives physicists a high-speed snapshot of electrical flow at any given exact moment. To sum this all up, our source material states we have various types of current that are used in everyday activities. And it's so true, right? We just flip a switch and rarely give a second thought to the complex structures making it all happen. But those invisible electrons are flowing in highly specific, carefully engineered ways, from undulating waves crossing utility lines outside to the steady, quiet push happening inside your smartphone.
So the next time you plug a device into the wall, take a second to think about that invisible translation happening right in the palm of your hand. Ask yourself, are you using the alternating current directly from the wall, or are you forcing it through a rectifier to capture that steady direct current for your battery? The power play is literally happening all around you. Thanks so much for joining me for this explainer, and I'll catch you next time.